Hello, this is Nick of Time. Welcome to this 8th talk in the series on time. This black and white picture of a clock reminded me that people who have entrenched views on a system, on a belief system, will tend to accept arguments that support that belief system without much critical thinking. They tend to take a black and white view of things. Whereas if they hear an argument that opposes or argues against their belief system, they will tend to dismiss it or just ignore it. That's why we like to call for critical thinking, because critical thinking reveals a much more multifaceted view of the topic. And we look at things in many different ways, from many different perspectives. Everything is not black and white, but has various shades of gray or even color. Last time, we talked about the twin paradox claim, so we'll do a short review. Einstein made his twin paradox claim, which implied that proper time accumulation rates change as a function of relative velocity. After deriving special relativity's time dilation, he said from this, obviously referring to special relativity's time dilation, if two clocks are at rest in an inertial frame next to each other, and one clock makes a round trip, then it will return having accumulated less proper time. We'll examine that claim. To continue our review, we know the critics of the special relativity twin paradox claim said that since time dilation was based on relative velocity, both clocks will be slower than the other, which is an obvious contradiction. Can't be true. Thus invalidating that interpretation of time dilation and validating the twin paradox claim. Well, the relativists agreed this was a problem. So, looking at the title, the relativists came up with a reconciliation argument. That phrase, reconciliation argument, refers to arguments that try to reconcile the twin paradox claim with special relativity. The second bullet describes that relativist argument. They say because the traveling twin accelerates, special relativity does not apply to him. It breaks the symmetry. Well, initially that sounds plausible and was accepted by the relativists, but we're going to apply critical thinking and look a little bit closer, a little bit deeper. For example, many things would break the symmetry, but are irrelevant. So we must apply critical thinking. Now I'm going to show a slide, and you may think I'm being kind of facetious, but here we see the picture of a twin paradox scenario. Well, we could say, look, one twin is dressed in blue and the other twin is dressed in gray. And that breaks the symmetry. But that's obviously not true, not relevant, has any meaning. But it makes the point that one has to examine the claim to see if it really is a relevant and valid claim. Here's the first rebuttal argument to the relativist's reconciliation argument. Nothing in the derivation or assumptions of special relativity says that prior or future accelerations means special relativity no longer applies for that clock or observer. Well, if the relativist argues with that and says, yes, there is something in the derivation or assumptions of special relativity that does say that prior or future accelerations mean special relativity no longer applies, then special relativity would be worthless. Because all atoms and objects and clocks and observers have had prior accelerations, and they will in the future have accelerations. So that will rule out using special relativity in any real-world situation. Einstein liked to use Gedanken experiments or thought experiments. So we'll apply some thought experiments to the twin paradox scenario. Note that one can arrange the twin paradox scenario such that the initial acceleration is replaced by an arbitrarily close flyby of the two twins and their clocks. And have that be the starting event. And which twin will turn around is not determined until after the initial separation has completed and one of the twins is selected to do the turnaround. Let's say that A's clock was selected to do the turnaround. Well, that would mean that A's clock, while it was separating prior to the turnaround, would have to retroactively slow down. Or, in other words, jump backwards in time. If it had recorded 1 year of travel time, it would have to jump backwards and, let's say, record half a year of travel time. And vice versa, if the B clock had been selected, then its clock would have to slow down retroactively or jump backwards. And we know that doesn't happen. That doesn't make sense. So that shows the reconciliation argument is bogus. Let's just give a picture of that. Unfortunately, most of these pictures of twin paradox show the starting point as flying off the Earth. And the Earth is kind of a singular point, so that makes one think of a preferred frame where a round trip and having one clock slow down would make sense. So we're going to ask you to mentally replace the Earth with the A twin being in a rocket, like these other rockets, but the rocket will be pointing in the opposite direction of the rocket that's above him. So we're saying that we don't have the two twins standing next to each other to start the round trip, but rather the B rocket is flying by to the right, and the A rocket is pointing in the opposite direction. Let's have these rockets be in deep space. So we don't really have any criterion, at least in special relativity terms, for saying which one is stationary and which one is moving. So from the A-frame's point of view, the rocket that replaces the Earth, from that frame, we have the top rocket, B's rocket, moving off to the right. But from the B frame's point of view, the A twin and the A rocket would be moving off to the left. So that's what we were talking about when we were saying we're replacing the starting event in the twin paradox scenario with an arbitrarily close flyby, where the two twins could compare clock settings without any problems of simultaneity. We obviously know when you have two particles collide, there's no question about the simultaneity of their being in the same place at the same time. And an arbitrarily close pass-by simulates a particle collision. It becomes arbitrarily close to being a collision. Okay, let's look at another argument. We'll take the flyby method and extend it, and we can get an acceleration-less scenario. We have arbitrarily close flybys for both the start and the end events. And we even have an arbitrarily close flyby at the turnaround. To do that, we have to have a third twin named C. And so they really become triplets. So at the turnaround, and let me just show that picture again. At the turnaround, we have the B twin flying off to the right, just below where it says event 2. About to go off the end of the picture. And we have a third twin, C. It's coming in like a rocket just above event 3 on the right. And when they're arbitrarily close, again, they can synchronize their clocks, and the C clock is set to whatever the B clock reads at that arbitrarily close encounter. And then C continues until it has an arbitrarily close encounter with the A rocket and the A twin that is moving off to the left. So there we've eliminated acceleration and eliminated the breaking of symmetry, or eliminated the construct of the relativists in their reconciliation argument. In that scenario, if we're to apply special relativity time dilation interpretation consistently, we would again conclude that the A clock is running, the combination of the B and C clock are slow with respect to the A clock, and vice versa. And you can't have two clocks both being slower than the other. Here we have a fourth rebuttal argument, and it's not really a QED argument, it's just seems like a fairly well-reasoned rational argument for one's consideration when doing critical thinking. And for a scenario, we can make the constant velocity parts of the scenario arbitrarily long compared to the time it takes to do the acceleration. So we create one where 99.9999% of the time both are in inertial frames, and hence one should not rule out a twin because of 1/1000th part or percentage of the time he accelerates. And for our fifth rebuttal argument, we have another Gedanken experiment where we say if the A twin does the same accelerations as the B twin's accelerations, A will come back to rest in the A frame at the starting location. Thus, the symmetry will be restored, including accelerations. So, when one applies special relativity consistently, that will lead to claiming that both the A and B clocks are slower than the other clock, thus showing the relativist reconciliation argument is bogus. In summary of this talk, since that argument is bogus, then the relativist cannot claim that it's okay to interpret special relativity's time dilation as describing physical clock slowing. Because if they do make such a claim, and then they apply that interpretation consistently, then they're claiming the A clock is physically slower than the B clock, and the B clock is physically slower than the A clock, which is an obvious contradiction. And the only way to get around that contradiction is to figure out some way to say that special relativity does not apply to one of the clocks. And, as we discussed in our first rebuttal argument, if they do that, then they show that special relativity is unusable in the real world. If that still does not faze the relativist, then they further have to deal with the 4 additional rebuttal arguments we just discussed. And the next talk will show that even if we allow the relativist to claim that special relativity does not apply to one of the clocks, the flaw in claiming that special relativity's time dilation can cause different clock rates is so deep that it can still be shown to lead to a contradiction. Thanks for joining us for this, our 8th talk. Hope you'll join us as we continue to apply critical thinking to special relativity's treatment of time.